Hi guys, trust you are doing good. In today's class, I'm going to provide solution to this given problem, and this is one of those tricky integration by reduction problems that can feel frustrating if you don't know the right approach to use here. But however, once you see the right method to use, you realize that it's actually simple to solve this given problem. Okay, now given that in equals integral 0 to 1 x1 minus 2x raised to the power of 4 in brackets raised to the power of n dx, then we should show that in equals this. Okay, so from the given question we have in equals integral 0 to 1, then x in bracket of 1 minus 2x raised to the power of 4 raised to the power of n dx. So first thing we need to do here is to rewrite this one in terms of in minus 1, and that can be obtained by rewriting the brackets, what you have in the brackets, and that can be written as 0 to 1 x 1 minus 2x raised to the power of 4, then 1 minus 2x raised to the power of 4 n minus 1 dx. I haven't changed anything here. By the time you multiply the brackets, you're gonna have the same results as what you were given. Okay, so looking at this, I'm gonna use x to expand the first bracket, and that's going to be x minus 2x raised to the power of 5, then 1 minus 2x raised to the power of 4, then n minus 1 dx. So I'm sure you are getting it. Okay, so use each of the first term in the first bracket to expand the second bracket. Okay, so when you do that, you have x 1 minus 2x to the power of 4 n minus 1 dx, and you're gonna have minus 2 integral. So I mean, this is going to be 2x raised to the power of 5 now. X times 2x raised to the power of 4, that should be 2x raised to the power of 5. Alright, sorry about that. So now you have 1 minus 2x to the power of 4, then n minus 1 dx. So when you look at the integrand of the first time here, it looks like what you were given, the given question, but the only difference there is the power. The power of in is n, while the power here is n minus 1. So for that reason, this is going to be I subscript n minus 1. So everything here can be written as I subscript n minus 1. Alright, so then minus 2 integral. So next thing is to find a way to integrate this or to simplify that. Okay, why am I doing this mistake again? So I forgot it, 2x raised to the power of 5 again. I'm sorry about that. So x raised to the power of 5 should be here, then 1 minus 2x raised to the power of 4, then n minus 1 dx. Okay, yeah, so to integrate this now, we're gonna make use of integration by parts, but then you can't just use integration by part like that. You have to rewrite it in a way that will be very comfortable or convenient for you to use the formula. All right, and that can be of this form: x squared times x cubed, then 1 minus 2x raised to the power of 4 n minus 1 dx. So the question should be, why do I have to rewrite x raised to the power of 5 as x squared times x raised to the power of 3? While solving this, I'm gonna need x to the power of 3, so it is better for you to write that out now, okay, so that it will help your solution at the long run. So now moving to this, you compare this. So let me just write it out. Let's call this to be equation 1. Then consider integral x squared times x raised to the power of 3 1 minus 2x raised to the power of 4 n minus 1 dx. So using integration by parts now, which is always in form of this u dv, so where u is gonna be x squared and dv is going to be x cubed 1 minus 2x raised to the power of 4 n minus 1 dx. Okay, yeah, so differentiate this. You're gonna have the u to be 2x dx, Okay, and when you integrate this, you have v to be. So to integrate this one, you're gonna use substitution method. You can just let p to be 1 minus 2x raised to power 4, and you start simplify that. But at the end, you're gonna have what's it called? If you let p to be this 1 minus 2x raised to power 4, that's going to be dp dx is minus 8x raised to power of minus 2x raised to power minus 8x raised to power of 3. So the x is going to be dp over minus 8x raised to power of 3. Okay, so I'm gonna remove this later, but let me just use that to explain. So by the time you make the substitution here, you have x cubed times p raised to power of n minus 1, then the x is what? dp over minus 8x raised to power of 3. And of course, x raised to power of 3, we cancel that. So you can see why we have to rewrite x raised to power of 5 in terms of product of x squared and x cubed now. Okay, so from here you could factorize minus 1 over 8, then you start to integrate pn minus 1. So in summary now, this is going to be minus 1 over 8n, then 1 minus 2x raised to power of 4 to the power of n. So let me remove this because we don't actually need that again. Don't need that anymore. Okay, so the next thing now is to make the substitution in integration by parts formula, where the formula is given to be u dv equals uv minus integral v du. Okay, so we have integral x to the power of 5 1 minus 2x raised to the power of 4 n dx. Okay, n minus 1, then dx equals u is x squared times minus 1 over 8n 1 minus 2x raised to the power of 4n, then minus integral v du. V is minus 1 over 8n 1 minus, I think I will need to adjust this space, sorry, let's take it again. U is x squared times this, that's going to be minus 1 over 8n 1 minus 2x raised to the power of 4, then to the power of n x squared, then minus integral minus 1 over 8n 1 minus 2x raised to the power of 4n, then du is 2x dx. So minus 1 over 8n 1 minus 2x raised to the power of 4n x squared. We'd factorize minus 1 over 8n, that's going to be plus 8n. Then 2 can also be factorized, and 2 over 8n is 4n. So you have integral, then x in bracket of 1 minus 2x raised to the power of 4, the n. So don't forget your what's it called, the interval, the upper bound and the lower bound, which is 0 to 1. So upper limit and lower limits, yeah. Okay, 0 to 1. So this is what you obtain for this. So let's call this to be equation 2. So now you substitute equation 2 now in 1. So in a place of, you replace what you have here with this. Okay, so which is in from 1 now, in minus 1, then minus 2 in bracket of, in bracket of this, minus 1 over 8n, then we could substitute the interval here. So when x is 1, if you put 1 here, 1 minus 2 times 1 raised to the power of 4, that's minus 1 raised to the power of n. So when you substitute 0 here, so everything here becomes 0, so I don't need to write that again. So let's just write 1 over 4n integral from 0 to 1 x 1 minus 2x raised to the power of 4, then n dx. There should be the x here. Okay, so you have in plus in minus 1 minus 2 times this, that's going to be plus 1 over 4n minus 1 raised to the power of n plus 1 over 2n integral from 0 to 1 x1 minus 2x raised to the power of 4 n dx. Okay, looking at this now, this is exactly what you are looking for, which is in. So for that reason, you change what you have here to be in. This is in, then in minus 1 plus 1 over 4n minus 1 raised to the power of n plus 1 over 2n. Is that going to be plus or minus? That should be minus, because by the time you use minus 2 to expand the bracket, that becomes negative there. So minus 1 over 2n in. So you rearrange that, in plus 1 over 2n in, then equals in minus 1 plus 1 over 4n in bracket of 1 minus, in bracket of minus 1 raised to the power of n. Okay, so you take xm here, this is going to be 1 plus 2n in, then over 2n equals in minus 1 plus 1 over 4n, then 1 minus n raised to the power of n. So what's the next thing to do here? So you can just multiply both sides by what? By 2n. All right, so we multiply both sides by 2n, that's going to be 1 plus 2n in equals 2n in minus 1, then plus that's 1 over 2, then this is minus 1 raised to the power of n. Okay, then the next thing is to divide both sides by 1 plus 2n. So in equals 2n, then over 1 plus 2n in minus 1, then plus minus 1 raised to the power of n over what? 2 in bracket of 1 plus 2n. So which implies that starting with this, you have minus 1 raised to the power of n. I use 2 to expand the bracket, that's gonna be 4n plus 2, then plus 2n, then over what? 2n plus 1 in minus 1. And this formula is valid when n is greater than or equals to 1, and that is what we are asked to show for. You can see that here. Okay, so don't forget to like, drop your comments and subscribe. Thank you.